And today we are going to discuss the topic based on the gate electrical measurement of energy and power. So based on this topic, we have year-wise questions with solution. So the first question is voltage across and current through a load are expressed as follows. So V of t equal to 170 sine 377t minus pi by 6 of V. And I of t is 8 cos 377t plus pi by 6 of A. So we have to calculate what is the average power in watts. So round off to one decimal place. So from source to load, what is the power consumption is needed in a three-phase system? So I have the four options: 340.5, 170.6, 588.9, and 377.8. So I have the option of 588.9 is the right answer. We have to check how the answer is arrived. So we know that V of t equal to minus 170 sine 377t minus pi by 6 of E equal to VPC. Likewise, I of t equal to 8 cos 377t plus pi by 6 of A equal to ICC. And I of t equal to 8 sine 377t plus 2 pi by 3 of A equal to ICC. So P average is nothing but half times of minus 170 into 8 cos of minus pi by 6 minus 2 pi by 3. So the answer is 588.9 watts. So the first question is over. You have the option C, 588.9. So second question is 2 wattmeter method is used for measurement of power in a balanced three-phase load supplied from a balanced three-phase system. If one of the wattmeter reads half of the other, both positive, then what is the power factor of the load? We have four options: 0.532, 0.632, and 0.707 and 0.866. We have to check which answer is correct. So if my voice is not audible and screen is not clear means please inform for me. So suppose I am checking the option A. So A is wrong. I have the option of a D. D is the right answer, 0.866. So we have to check how the answer D is arrived. In 2 wattmeter system, we know that tan pi equal to root 3 W1 minus W2 divided by W1 plus W2. So from this we can extract W2 equal to W1 by 2. Obviously, for tan phi equal to root 3 W1, in place of W2 I have to substitute W1 by 2. Likewise in the denominator also W1 plus W1 by 2. So my pi should be replaced by 30 degrees. So cos of pi, cos 30 is nothing but 0.866. So D is the correct option. So 0.866 is the correct answer. Next to question number 3. The load shown in the figure is supplied by a 400 volt line to line three-phase source RYB sequence. The load is balanced and inductive. Drawing 3464 VA. When the switch S in the position N, the 3 watt meters W1, W2, and W3 read 577.35 watt each. If the switch is moved to position Y, the readings of the wattmeter and watts will be. So it is connected in a zigzag fashion. So the 3 wattmeter readings is known to us, W1, W2, W3 read 577 if the switch is moved to the Y position. So in N position, the value is 577.35. Suppose the position of the switch is moved from N position to Y position. I mean, what is the reading? The deflecting reading values. So A is W1 1732, W2 W3 0, or B W1 equal to 0, W2 equal to 1732, W3 is 0, or otherwise C equal to W1 866, W2 is 0, and W3 is 866, or otherwise W1 W2 is 0, W3 is 1732. So we have to check which one is correct. So B is the correct answer. W1 W2 equal to 0 and W3 equal to 1732. So So we have to check how the answer is obtained. When switch is on neutral side, W equal to W1, W2 plus W3. So 577, 577, 577. So each and every value have 0.35, you have to add it. So 1732 watts. So my volt ampere load equal to 3464 is nothing but 3 times of V phase I phase. So V phase I phase is nothing but 3 times of 3464. So 1154.66. Each ohm meter reading VRN IR cos phi at an angle VRN and IR. So 577.35 equal to V phase I phase cos phi. So cos phi equal to 0.5. So pi equal to cos inverse of 0.5 is nothing but 60 degree. When the switch is on Y phase side, W1 equal to VRY IR cos VRY plus IR. So W1 you will get a 0 only. W3 is also W3 is VBY IR cos VBY and IR. You will get 1732 watts. So obviously your W1 W2 is deflecting 0. W3 should be deflecting on 1732 watts. Hence your option should be D. W1, W2 is 0 and W3 equal to 1732 watts. So next is an energy meter having meter constant of 1200 revolutions per kilowatt hour makes 20 revolutions in 30 seconds for a constant load. So the load in kilowatt is, so A is 1, B is 2, C is 3 and D is 4. So we have to check which one is correct. So 2 is the correct option, 2 kilowatts. So P loss is nothing but revolutions, that is 3600 into 20 by 1200 into 30, 2 kilowatts you will get. So option B is the correct answer. So question number 5, the coils of a wattmeter have resistances 0.01 ohm and 1000 ohm. Their inductances may be neglected. The wattmeter is connected as shown in the figure to measure the power consumed by a load, which draws 25 amps at power factor 0.8. The voltage across the load terminal is 30 volt. The percentage error on the wattmeter reading is. So what is the percentage of the error in wattmeter reading? So A is 0.85, B is 0.15, and C is 0.25, and D is 0.5. So B is the right answer. So the value of instantaneous power is VA cos phi, 30 into 25 into 0.8, 600 watts. The given diagram measured power equal to power loss in pressure coil plus power in load. So V square by R pi plus VA cos pi. So 30 square by 1000 plus 600 watts equal to 600.9 watts. So in order to find out the error in wattmeter reading, our LATEX is nothing but measured value minus true value by true value. So 600.9 minus 600 by 600 into 100, 0.15%. So option B is the correct answer. So question number 6, a three-phase balanced load which has a power factor of 0.707 is connected to a balanced supply. The power consumed by the load is 5 kilowatts. The power is measured by 2 wattmeter method. The readings of the 2 wattmeter are. So we have 4 different options. We have to check which one is correct. So A is the right answer. Fortunately, I clicked answer is right one. So 3.94 kilowatts and 1.06 kilowatts. So power factor should be 0.707 given in the problem. While taking cos inverse of the power factor, you will get the phase angle 45 degree. Your power should be 5 kilowatt. W1, W2 equal to 5. So tan phi is nothing but root 3 times W1 minus W2 divided by W1 minus W1 plus W2. So W minus 1 plus W2 into 1 equal to root 3 W1 minus W2. So W1 minus W2 equal to 5 by root 3. So from first and second expression, we have W minus 1, which is equal to 3.94 kilowatts. So when you are bringing W2 in the previous expression, either we have to substitute in first expression or second expression. So you will get the W2 value 1.06 kilowatt. So option A is correct. So question number 7, an LPF wattmeter of power factor is 0.2 is having three voltage settings: 300 volt, 150 volt, 75 volt, and two current settings: 5 amp and 10 amp. The full scale reading is 150 if the wattmeter is used with 150 voltage setting and 10 ampere current setting. The multiplying factor of the wattmeter is. So the multiplying factor is 2. How the value is 2 means, so cos pi equal to 0.2 LPF wattmeter, full scale reading of wattmeter WM equal to 150 watt. Also for V equal to 150 volt, so W equal to VA cos pi. There's nothing but 150 into 10 into 0.2 is 300. Therefore, multiplying factor of wattmeter is W by WM, 300 by 150, which is equal to 2. Question number 8. While measuring power of a three-phase balanced load by the 2 wattmeter method, the readings are 100 watts and 150 watts. Power factor of the load is. So, what is the power factor of the load? Either 0.2 or 0.48, 0.8 or 0.96. So, C is the right option. So, the value is 0.80. So, W1 equal to 250, W2 equal to 100. Power factor angle is given by phi equal to tan inverse of root 3 W1 minus W2 divided by W1 plus W2. So I am substituting all the values. I will get phi as 36.58. So cos pi, cos of 36.58 is nothing but 0.808. So 0.80, the 2-point accuracy is needed. So ninth question. Power consumed by a balanced three-phase, three-wire load is measured by the 2 wattmeter method. The first wattmeter reads twice that a second. Then load impedance angle in radians is, so pi by 2, pi by 8, pi by 6, and pi by 3. So which one is correct? So C is pi by 6 is correct. So phi is 30 degree means it is pi by 6. So here W2 equal to 2 times of W1. In the first question or second question, we discussed W1 equal to 1 by W2. So half times. 10th mark. For the circuit shown in the figure, the voltage and current expressions are V of t equal to E1 sin omega t plus E3 sin 3 omega t, and I of t equal to I1 sin omega t minus pi 1 and I3 sin 3 omega t minus pi 3 plus I5 sin 5 omega t. So the average power measured by the wattmeter is. What is the average power measured? In terms of equation they are asking. So supply voltage is V of t and circulating current is I of t. We have the load and wattmeter is connected. And what is the average power measured there? So the average power measured is half times of E1 I1 cos pi 1 plus E3 I3 cos pi 3. So option C is right. So it is just a mathematical expression only. So in our basic circuit analysis, you have three-phase power. The same three-phase power you may study in your measurements and instrumentation paper also. These are all elementary theories which you learned in your second semester or your fourth semester. So consider the following statement. So it is a statement-based question. 11th question, number 11. So the compensating coil of a low power factor wattmeter compensates the effects of the impedance of the current coil. And second one is the compensating coil of a low power factor wattmeter compensates the effect of impedance of the voltage coil circuit. So which statement is correct? Either A true, B false, or A is false, B is true, or both 1 and 2 are true, or both 1 and 2 are false. So what is the statement is correct? So B is correct. Correct. 1 is false. So the compensating coil of a low power wattmeter compensates the effect of impedance of the current coil. So it never obeys. So second statement is valid. The compensating coil of the low power factor wattmeter compensates the effects of impedance of the voltage coil circuit. So next is question number 11. You have the circuit coil, sorry, current coil, compensating coil, and you have supply and load. You have the wattmeter windings. So the statement is the current coil. So the explanation is clear. So 12th question. A wattmeter is connected as shown in figure. The wattmeter reads. You have current coil as well as potential coil as a wattmeter block. You have the impedance Z1 and Z2. So what is the wattmeter reads? So 0 always total power consumed by Z1, Z2, power consumed by Z1 or Z2. So what is the answer? So D is the answer, power consumed by Z2. How it is happened? So the potential coil draws negligible current. So current through Z1, Z2 is same. Current through current coil is ICC equal to I. Voltage across potential coil is VPC. So voltage across Z1 is VPC equal to V. Wattmeter reads power consumed by Z2 as voltage across the potential coil, voltage across Z2, and current through current coil is current through Z2. So only the voltage reads is Z2 value. 13th question. So the figure shows a three-phase delta connected load supplied from a 400 volt 50 Hz three-phase balanced source. The pressure coil PC and current coil CC of a wattmeter are connected to the shown the load as shown. With the coil polarity suitably selected to ensure a positive deflection, the wattmeter reading will be. So we have three sides of delta connection. Z1 we have, Z2 we have, and CC we have current coil and potential coil. And which reading should be? So the power should be 800 watts. The meter reads. So assuming phase angle sequence ABC, line to line voltage is 400, taking VAB as the reference, VAB equal to 400 volts and VBC equal to 400 at an angle minus 120 and VCA equal to 40 at an angle 240. So ICC equal to VCA by Z2, 400 at an angle minus 240, 100 by J0, 4 at an angle minus 240 amps. So voltage across pressure coil is 400 at an angle minus 120. So phi equal to angle between ICC and VPC. So minus 120 minus 240 which is equal to 100 degrees. Wattmeter reading is IPC VCC equal to cos pi 400 into 4 into cos 120. So it is 800 watts. So the pressure coil of a dynamometer type wattmeter is highly inductive, highly resistive, and purely inductive. So it is highly resistive. It is difficult to have the purely resistive pressure coil. So the pressure coil has a small value of inductance due to which error occurs in the wattmeter readings. So 15th question. A sampling wattmeter that computes power from simultaneously sampled values of voltage and current is used to measure the average power of a load. The peak-to-peak voltage of the square wave is 10 volt and the current is triangular wave of 5 amps point to point as shown in the figure. The period is 20 milliseconds. The reading in watts will be. So either 0, 0 only, 25, 50, 100 or 1. You have to check 0 is correct or not. So positive power equal to negative power, so average is 0 only because it is a zigzag configuration. 2 wattmeters which are connected to measure the total power on a three-phase system supplying a balanced load. Read 10.5 kilowatt minus 2.5 kilowatt respectively. The total power and power factor respectively are 13 kilowatts 0.334 and 13 kilowatt 0.684 and C is 8 kilowatt 0.52 and D is 8 kilowatt 0.334. So which one is correct? So D is the right option, 8 kilowatt 0.334. So P1 equal to 10.5 kilowatts, P2 equal to minus 2.5 kilowatts. So total power is 8 kilowatts. So cos pi equal to cos tan inverse of root 3 P1 minus P2 by P1 plus P2. So the value is 0.334. So 17th question, a single phase load is connected between R and Y terminals of your 415 volt symmetrical three-phase four-wire system with a phase sequence RYP. A wattmeter is connected to the system as shown in figure. The power factor of the load is 0.8 lagging. The wattmeter will read. So minus 597 watts. So line to line voltage is 450 volt and the phase to neutral is 415 by root 3 volt. Taking VR as the reference, VRN equal to 415 by root 3. So VYN equal to 415 by root 3 at an angle minus 120. VBN is 415 by root 3 minus 240. VRY, VR1, VY1 equal to 415 at an angle 30 degree. The load current is 4.15 at an angle minus 6.87. So ICC equal to IL 4.15 at an angle minus 6.87 amps. Voltage across pressure coil is VBN equal to 415 by root 3 at an angle minus 240. So 5 is 233.13. So the wattmeter reading should be 415 by root 3 into 4.15 into cos 233.13 minus 597 watts. So a DC ampere meter, ampere hour meter is rated for 14 amps 250 volt. The meter is constant 14.4 amp seconds revolution. The meter constant rate voltage may be expressed as so 370 revolution per kilowatt kWh, 3600 revolution per kWh, and 1000 revolution per kWh, and 960 revolution per kWh. So which one is right? So the answer is 1000 revolution per kWh. So for 1 watt hour, 1 kilowatt hour, you have 1000 revolutions. So the meter constant is 14.4 ampere second per revolution. To express the meter constant in the unit revolution per kilowatt hour, so meter constant is 1 by m, that is 1 by 14.4 revolution per ampere second. So the value should be 1000 revolution per kilowatt hour. So 19th question, in the circuit and figure is used to measure the power consumed by the load. The current coil and the voltage coil of the wattmeter have 0.02 ohm and 1000 ohm resistances respectively. The measured power compared to the load power will be so 1000, 0.02 ohms and 20, 200 volt UPF load. So 0.4 percentage less, 0.2 percentage less, 0.2 percentage more, or 0.2 more. So which one is correct? So load true power is VA cos pi 200 into 20 into 1, which is equal to 4000 watts. The resistance of current coil is 0.02 and current through CC is 20 amps. Power consumed by current coil is IC square RCC. That is 20 square into 0.02 equal to 8 watts. So the percentage error is measured power minus true power by true power into 100. So 4008 minus 4000 by 4000, which is 0.2 percentage more. So 20th question, the voltage flux adjustment of a certain single phase 220 volt induction watt hour meter is altered so that the phase angle between the applied voltage and the flux due to its 85 degree instead of 90 degree. The errors introduced in the reading of the meter when the current is 5 ampere at power factor of unity and 0.5 lagging respectively are so 3.8 milliwatt, 77.5, 77.4 milliwatt, or otherwise minus 3.8 milliwatt, 77.4 milliwatt, or minus 4.2 watts or minus 85.1 watts. So D is 4.2 watts or 85.1 watts. So which one is right? So C is the right option. So minus 4.2 watts minus 85.1 watts. So measured values VA sine delta minus phi, where delta equal to phase angle between voltage and flux, cos pi equal to power factor. True value is VA cos pi, error is measured value minus true value. So case 1, when delta equal to 0, power factor equal to cos pi 1 and phi is 0, V is 220, I is 5 amps. So error VA sine del minus phi minus VA is cos pi is minus 4.2 watts. So likewise we have to Andy அவனுக்கு பசி தான் எடுக்குது. So 21st question. So a wattmeter reads 400 watts when its current coil is connected in the R phase and its pressure coil is connected between this phase and the neutral of the symmetrical three-phase system supplying a balanced star connected at 0.8 power factor. Inductive load. This phase sequence is RY. P. What will be the reading of this wattmeter? If its pressure coil alone is reconnected between B and Y phases, all other connections remain as before. So either 400, 519.6, 300, 692.8. So the answer is 519.6. So taking VR as a reference and assuming the phase to neutral voltage as V, and VR is V at angle 0, Vy is V at angle minus 120, and Vb is V at angle minus 240. So VR IR cos pi equal to 400 watts, VIR into 0.8 equal to 400 watts, VIR equal to 400, IR equal to IR times of minus 36.87. And VYB equal to VYB minus VB, V at an angle minus 120, V at an angle minus 240, root 3 of minus 90 volts. So IR equal to IR minus 36.87 amps. So angle between VRYB and IR is theta, which is equal to minus 90 degree of minus of 36.87, 53.13. So from the equation 1, you have to get 3V IR cos 53.13. So it's nothing but root 3 times of 500 into 0.6. So it is 519.6 watts. So the line-to-line input voltage of 350 Hz AC circuit shown in figure is 100 volt RMS. Assuming that phase sequence is ROB, the wattmeter would read. So RYB, W1, W2. So you have star equivalent impedances, 5 at an angle 60 degree. So what is the corresponding W1 and W2 should be? So C is the right option. W1 is 0 watts and W2 is equal to 1000 watts. So VL equal to 100, IL IP equal to VP by Z. Is equal to 100 by root 3 times of 5 into 60. So 20 by root 3 is minus 60 degree. W1 equal to VLIL cos 30 degree minus alpha. So 2000 by root 3 cos 90 degrees. W2 equal to VLIL cos 30 degree plus 5. So 100 into 20 by root 3 cos 30 degree minus 60 degree 1000 watts. So the minimum number of, next question is the minimum number of wattmeters required to measure three-phase, three-weight balanced and unbalanced power is. So it is 2. So 2 wattmeter method can also take care of unbalance. So 2 is enough. So in an energy meter, disk makes 10 revolutions in 100 seconds. When a load of 450 watts is connected to it, the meter constant in revolution per kWh is. So it is 800. So we have to check how 800 is arrived. So 800 watts is not given. Detailed solution is not here. So once you are appearing for the gate examination, you have to check the topics. So unit wise, you have to practice the questions. So I found this the website when I'm googling. So practicepaper.in. So name of the website is practicepaper.in. So you may found all type of competitive examination in this site. So gate CSE, gate mechanical, gate CEC, and gate triple E. We have subject notes. You have sufficient amount of subject notes, and the topic wise you have the questions. So we have 10 chapters. As I am mentioning in the previous classes, your gate electrical engineering having 10 different topics. So you have general aptitude, it is numerical ability and verbal ability you have, and then engineering mathematics you have. So engineering mathematics, English you have. In the numerical ability and verbal ability, you have English also. So general questions also you have. And engineering mathematics, you have linear algebra, calculus, differential equations, complex variable, numerical methods, probability and statistics. And the first topic is in department wise, it is electric circuits. It is common to EC and triple E. And next is electromagnetic theory. It is in terms of electromagnetic fields. It is also common to EC and triple E. And signals and systems. This is also common to EC and triple E. An electrical machinist purely belongs to electrical department. So you have DC machines, single phase induction motor, special purpose machine, and EMC, electromechanical energy conversion, synchronous machine, and three phase induction machines, transformers like that. And then power systems. You have compensation technique, distribution system, cables and insulators, economic power generation, and load dispatch. So you have a high voltage DC line, load flow studies, per unit system, performance of transmission line, line parameters and corona, power system stability, transients, switchgear and production. So many topics you have in your power system. The power system plays a major role in GATE examination. So if you are familiar with power systems, you will get 18 to 22 marks in power system. Next is electrical and electronic measurements. You have AC bridges, characteristics of instruments and measurement systems, CR1 electronic measurements, galvanometers and voltmeters and ammeters, instrument transformer, measurement of energy and power, measurement of resistance and potentiometers. So these are all things available in M&A. And you have digital electronics, A by D, D by A converter, Boolean algebra, logic circuits, logic families, logic gates, microprocessors, sequential circuits. You have a lot of topics. And control systems, you have concepts of stability, design of control system, feedback, frequency response, mathematical models, root lockers, stability, and time response. And in power electronics, you have choppers, electrical drives, inverters, phase control, phase, power semiconductor devices, and commutator. And miscellaneous questions you have based on the circuit area also you will get in power electronics. Next is analog electronics, BJT, FET, and their biasing circuits, diodes and their application, operational amplifiers, oscillators and feedback amplifiers, small signal analysis, miscellaneous topics, and general ability. You have numerical ability and verbal ability. So these are all the topics you have. So why I am insisting all the topics means in this site you have all the topics in the objective question pattern. Year wise you have the questions with the solutions. So if I am checking with the phase control rectifier, you have various questions year wise. 2020 the question is asked. If you are checking the question wrong, also no issues. So once you learn the question with the detailed solution, once again you may appear for the same question. So practice one time to so many times when you get 100% of the accurate results. So while you're practicing more and more, you will get a good score in the GATE examination. So why I am insisting the GATE score is important means because most of our central government organizations, they are taking GATE score as their written test. Based on their GATE performance, they will directly calling for your interviews. So central government job is not an easy task. So you have to prepare more and more for this examination. So concentrate the GATE examination for more for this topic. So give importance to all your topics and prepare your examinations well.